Hello students, now we will be solving this problem related to torque. In this problem I have a bolt here, bolt that I'm trying to tighten using a wrench. Okay, so the wrench is 25 centimeter long. 25 centimeter. I'll be reading now the problem. A bolt of a car engine must be tightened with a torque of 35 newtons. So the first thing, we are given the torque and it is equal to 35 newton times meter. This is the SI unit for the torque, and as we said, we give it the symbol tau. We are using a 25 centimeter long wrench and pull at the end of the wrench with a force. This blue arrow is the force, and this force is, as you can see, not perpendicular, it's tilted, it's making an angle of 60, so theta equals 60 degrees. 60 degrees to the handle of the wrench. In part A, we need to calculate the lever arm, so the quantity L, lever arm, and we need to calculate the force that we need to exert in order to do this torque, which is 35 newtons. First of all, the formula of the lever arm is equal to R sine theta. R is simply the distance between the pivot point and the force, which is 25 newtons. 25 centimeters, and for sure I cannot accept it in centimeters. I'll be dividing this distance by 100, so it's 0.25 meters. So L is equal to 0.25 multiplied with sine the angle, which is 60 degrees. Make sure here that your calculator measures in degrees. In order to get the correct answer, it should be 0.22 meters. Now, to find the force that is required to apply this torque, I need to go to the formula of the torque, which is lever arm times force, or F times lever arm. 35 equals the lever arm by the force. To find the force, divide by 0.22, divide by 0.22. The force equals 159, or around 160 Newton. This is for part A. Okay, so now I cleared the board in order we solve part B together. They are asking us what force is needed if it's applied to the wrench pointing perpendicular to the wrench. Means what if the force was pointing this way, perpendicular. For sure, you must put in your mind that perpendicular force means the rotation will be easy, so I will need less force in order to do this torque, which is given and fixed. I can rewrite it here. It is 35 Newton times meter. Now here, what's different that if the force is perpendicular, then theta will be just 90 degrees. Theta between the wrench itself, or the axis, the line connecting the axis of rotation and the force, which is R, will be 90 degrees. So I will apply now torque equals the force multiplied with lever arm, which is R sine theta. We'll do it in one step this time. They're not asking me about the lever arm. So torque will be, here I can just write 35 equals, instead of the torque, equals the force times 0.25 sine 90. We know that sine 90 is just 1. So I'll be dividing both sides by 0.25, divide by 0.25, so the force here will be 140 Newton, which is, as we expected, less than 160, less than the force needed if we apply the force at an angle. If we apply it as perpendicular force, the force will be less. And actually, if you take a look about this quantity, here R sine theta, which is L, it will be just this value, 0.25, because as we said, sine 90 is just 1. So here the perpendicular distance, or the lever arm, is just the length of the wrench itself, which is 0.25 meters.